Hello, my dear grade 11 advanced students. Welcome to my channel Mathematics Made Easy. This is Ms. Ruchika welcoming you to another video on my channel, especially for your coming term 3 exam. So this is the revision series where we are covering important questions from exam coverage. And today in this video, we are continuing with our revision of lesson 9.7, the binomial theorem. This is a must-watch video, and I have made a video before this on the same lesson. Make sure you have seen that video, and I will put the link in the description box so that you can watch it if you have not done that so. In today's video, we are going to be covering some important questions. I have taken some questions in this video from part 2 of your exam coverage that has come for the exam. In this video, we will be covering example 4, that is question 23 to 28, which are given in your math book on page 596. So without much ado now, let's get started into the video and see what we are learning today. In my previous video for you grade 11 advanced students, I have shown you how you can use the binomial theorem to expand power of binomials. We had covered these questions in my last video. If you did not watch it, please go to my channel, and I will also put the link in the description box so that you can watch it before you continue understanding this video. In your exam coverage that has come for grade 11 advanced, we have questions on this lesson binomial theorem in part 2, where the learning objective is number 20. And here, because these are questions in part 2, they are going to carry 5 marks each. So please show the steps nicely for each of these questions. So we are covering in this slide example 4 and questions 23, 24, 25, 26, 27 and 28. So let's see what formula we're using for this question on binomial theorem and solve them one by one. So as you saw in the last video and even in this video, we are going to be using the binomial theorem to expand power of binomial. Recall from the last video and our previous session that we have the combination formula NCR equal to n factorial divided by r factorial multiplied with n minus r factorial that can be used to get the binomial coefficients, and the binomial theorem can be used to expand the binomial. So we are going to use this concept for solving the questions today. Let's recall from our previous video on binomial theorem, the expansion of binomial theorem and how we can use it to expand the powers of binomials. So the binomial theorem is used for the expansion of the binomial a plus b to the power n. This is what we are expanding, and we can write the binomial coefficients using the combination formula. So the first binomial coefficient will be nc0, then nc1, then nc2, followed by till we come to the last term with ncn. And first we take the first term, that is a, raise it to the maximum power n, then the second term raised to the power 0 so that the sum of the term is n. Then you reduce the power of the first term a by 1, it becomes a to the power n minus 1, and increase the power of the second term b by 1, so it becomes b1. Next term is an minus 2 b square, and the last term will be a0 b n. We can also write this expansion using the sigma notation. You already know sigma is this symbol. It's a Greek symbol and it denotes summation. So as you see, we are adding the terms one by one, so there is addition in between. So we can use the sigma notation here with k starting from 0 to n. The lower bound for k is 0, the upper bound is n, and we can write the combination formula. This actually is nck if you see carefully. So it is nck, and we have used the combination formula that nck can be written as n factorial over k factorial multiplied with n minus k factorial multiplied with a to the power n minus k and multiplied with b to the power k. So I hope you remember from the last video binomial theorem, and let's now use it for solving questions. So in today's video, we have taken from the exam coverage that has come for all of you grade 11 advanced students. Question which is given for learning objective 20, where you use the binomial theorem to expand powers of binomial. These questions 23 to 28 are given in your math book on page 596. As you see on this slide, for questions 23 to 28, I've already provided you the final answers in pink. The method to solve all of them would be same. So we are going to be solving two questions here in this video, that is 23 and 25, and you can similarly follow the method to solve the remaining questions. So here the key rule that we are going to use is that we will use the binomial theorem to get the binomial coefficients, and the formula that we are going to use is that the binomial coefficient of the kth term in the expansion of a plus b to the power n. So we are taking the binomial. You use the formula of combination NCR, and here you will take your R to be k minus 1. Now you must be thinking, what is n, what is R, what is k? So let me give you an example for 23 question. So first of all, k is the term that you have to find in the question. So for example, if we go to example 4 question 23, you have to find the third term. So k is going to be 3 here. So if k is 3, then what will be R? R will be 3 minus 1, so 2. N is the power of the binomial. So here the binomial which is given, let's write it again. First term is x, second term is 2z, and it is raised to the power n. So n is 7. So now that you have got, let's highlight the value of n, value of k, and the value of r. I will write here again, r is 2. So once you have all these three things, you may use, as you see in the formula, the formula for NCR. In case you have forgotten, I will write the formula again for combination. So we are going to use these formulas and the values of N and R to get our answer. So let's solve the complete question 23 and 25 in the next slide. Okay, so now that we have the value of N, K, R, we are using NCR formula. So we are calculating the binomial coefficient. So N is 7. See, we have got 2, so this is going to be 7 factorial over 2 factorial multiplied with 7 minus 2 factorial. So just simplify 7 factorial over 2 factorial over 5 factorial. So you may get this value directly from your calculator. If you're not using calculator, you may do it manually in this way. So open the numerator till you get the highest term of the factorial. So 7 factorial we opened as 7 multiplied with 6 till 5 factorial. I did it only till 5 factorial because I will cancel with this 5 factorial which is in the denominator. So now it cancels, and this is 7 multiplied with 6, 2 into 1. So this is, on simplification, 21. So that's the binomial coefficient. Now we need to get the third term. So we will complete the solution now. So third term in this binomial expansion, as you would see, if I use the binomial theorem for this expansion, x plus 2z to the power 7, you know we start from the first term, x to the power 7, and then for the second term the power is 0. Next value, you decrease the power of the first term by 1, so x to the power 6. Increase the power of the second term, so it becomes 1. And the next term is going to be x to the power 5, 2z to the power 2. Now I'm not writing more terms. The reason is because in the question only the third term is asked. So this is the first term, second term, and third term. We still have to write the binomial coefficients. It's going to be 7c0, 7c1, and 7c2. Now if you look carefully, 7c2 we have already evaluated. 7c2 has come out to be 21. So I can replace this term. This is my third term. This is what I need. So answer is actually this, from where 7c2 has already been evaluated as 21. So the third term is going to be 21, and you have x to the power 5, and now 2z whole to the power 2. So I can write 2 square z square. Now 2 square is 4. Multiply 4 with 21. So this is 21 multiplied with 4, x to the power 5, z to the power 2. The final answer here, For the third term is 84 x to the power 5 z power 2. Your answer for this question, it was asked for the third term, so final answer. The third term of the binomial expansion x plus 2z to the power 7 is going to be 84 x to the power 5 z to the power 2. So I hope you've understood how we get the indicated term of the expression using binomial theorem and combination formula. Let's do now in the next slide, question 25. Here in this question, we have to find the seventh term. That means the value of k is going to be 7. So your r is going to be k minus 1, which is 7 minus 1 or 6. So we know the binomial coefficient is given by NCR. N is the maximum power here, which is 8. So 8C6 is going to give you the binomial coefficient. When you open it using the combination formula and simplify, this is going to be coming out to be 28. So we have got the binomial coefficient. Now let's expand using binomial theorem the given binomial. So the binomial that is given in the question has first term 2a, second term minus 2b to the power 8. Now before I open this binomial, I will change the sign. That is, I will write minus as plus and then minus 2b as the second term. Okay, now I can expand using binomial theorem. I have to expand till this seventh term, so I will keep on doing that. Now, because you already know the method, so I will write the binomial coefficients quickly. So we start from 8C0, then 8C1, then 8C2, then 8C3, 8C4, 8C5, 8C6. I'm writing till 8C6 because that is the term of 7th, which we have already calculated, 28. Now we write the first term raised to the power maximum, second term to the power 0. Next term, 2a reduces by 1, minus 2b power increases by 1. 2a power reduces by 1, minus 2b power increases by 1. Now writing all these terms is completely optional. Once you get into the habit of solving many questions on binomial theorem, you will become proficient and you will not be requiring to write all the terms. You may just directly come to the term that is being asked in the question, that is the seventh term here, which is going to be this. So I'm going fast now. I'm just writing the terms quickly. And at each step you have to make sure that the power is equal to n. So 3 plus 5, 8. So we are correct. Now comes the term that we want. This is actually the term that I'm now going to write is the seventh term. This is the term that you want. So 2a, the first term, gets reduced by 1. So it becomes power 2 and minus 2b increases by 1. So this is the term that we actually need. So let's now simplify this term and write in a form that we can write for the answer. So 8c6, 8c6 already I have got 28. I will just put in the number here, and then you have 2a whole to the power 2. So this is 2 square a square. Now remember, there is a negative sign but the power is even, so eventually we will only get positive answer. So this is minus 2 to the power 6 b to the power 6. Now there are a lot of numbers here. Let's see. So 28 is going to be multiplied by 4. It is going to be multiplied by 2 to the power 6. So this big number you can get it quickly on your calculator, and the variables that are left are a square and b6. So a square b6. Multiply all these numbers, simplify, and when you do that, this will come out to be 7168 a square b6. So this is your seventh term, which is your answer for this question. So now you can check all your answers for question 23 to 28. We've already done 23 and 25. In a similar way, please solve the remaining questions. Check your answer, and with that, this learning objective 20, where we use the binomial theorem to expand power of binomials and find the indicated term of an expression, is complete. I hope you found the video useful, and if you did, give it a thumbs up, like, share and subscribe to the channel. and stay glued for more revision videos. Thank you for watching this video. This is Ms. Ruchika signing off from today's session. See you in my next video. Bye students.